Hello, welcome to the long-awaited video for the introduction to Mach 4. In Mach 4 we really wanted to get a modular design, and 3 was a monolithic program. The modularity of 4 is going to be shown in the directory structure, and I think that's probably the most appropriate place to start. So we're going to look in my Mach 4 folder here, and some of the files that we really need to look at are the Mach 4 core. This is the meat of Mach 4. Mach 4 has many features built into it that are all plugin based. So Mach 4 core is the central hub of the software. On top of that, we've got things like Mach 4 GUI. This will run screen set files. And what we've been testing quite a bit lately is WXMach. This is a static screen. We have the configuration files, which is the coreconf.dll. That's how you can set your motor tuning and everything else. Let's see, we've got the IPC. This is for remote connecting. We have IPC for remoting into the GUI. GCEdit is our text editor for editing G codes. It also can display the toolpath and so on. The Lua editor is our scripting editor, and as we come up we can see we have another directory called plugins. This is where we'll add things like the Lua scripting language, Modbus, registers. This kind of replaces how DROs worked in Mach 3, except they can be expanded by users, and we'll go over that. And the SimDLL is what we're using for motion. Mach 3 was able to do motion internally, but Mach 4 is not able to. The motion device drives the software, which is how we got a lot of the latency issues out. So we need a motion device to even allow you to simulate motion. As we move down, we've got the screen sets. They're set files. I've got some other stuff that landed in here. Let's see, we've got the wxmach.set, and the screen sets are not compatible with Mach 3. The set files are actually zip archives, so I'm going to rename it. Yes, we'd like to do that. And we're going to look inside it, and as we can see we have images in screen.xml. So inside of every set file there'll be all the images for all the various items that we'd like to have in our screen for graphical entities. And the XML file has the layout, so we're using it as a real markup language. You don't need to know anything about this other than your images. There is no more bitmap directory. All the screen data travels with the screen set itself. So let me change that back, and in a later video we'll actually open that screen and we'll have a look at it. Then we have a wizards directory. These are Lua scripts. We can open up the Lua editor or use something like Notepad++ to look at them. We'll go into those in greater detail. They're a little more complex than the old wizards, but it's been our experience that most people that program them have a little bit of programming experience anyways. And then we're going to go into the profiles directory. This is for each profile that we'd like to have for machine configuration. So as we go in, we can see now there is another whole set of directories. We used to have XML files in Mach 3 that was for each profile. Now every profile is actually a directory with all the pertinent data for that particular profile. We did this so that as we ask for support things and ask you for your profile, you don't have to go to your macros directory, grab your macros. You don't have to go to your fixture library and grab that. You don't have to grab pieces from everywhere. Everything is contained under one directory, so you can zip it up and send it to us. So we'll look at the Mach 4 test profile, and in here we can see there's backups. In this backup directory, it backs up every time you run your software. We do up to 20 backups, and it's kind of a rolling 20. That allows us, you know, if you have a bad configuration, you can roll back and load up a new one. The fixture tables are in here. You could change this out if you'd like. Mach 4 is totally capable of loading multiple fixture tables. Our macros, The macros are a little bit different. We're using Lua for our scripting languages here. MCC is a compiled script. This is the source. If you're doing a project where you do not want to distribute the source for your scripts, you do not include the MCS files, only the MCC files. And everything gets compiled into one big chunk called mclua.mcc. And this is what is run by Mach. If we wanted to look at one of these, we'll just open it up in Notepad++. And here we have, I don't think you can see that, but let's see if you can. It's just getting the instance, setting an error, and sleeping for 5 seconds. A little test script. But as you can see, that has source code. Whereas if we go to open this one up, we'll see that it's nothing but compiled code. So that is the same script. Now we'll back out a directory, and we have our tool table data is in here. The tool and fixture tables both are capable of being human editable. So here you can see all the type, offset, where, y offset, z offset, radius. So it's fairly easy to work on. So you can edit them by hand if you'd like and print them off and look at them. We can also make a prettier print format. All your machine settings for each profile are saved as a machine.ini file. This also can be edited in Notepad if you would like. And as you can see, there's all your machine settings. So the default mode, the tool path, we were running an Ethernet smooth stepper, its various settings, spindle ranges, some stuff for a HICON. As you can see, we've been running many things, the multiple signal names. That concludes kind of the directory structure of Mach4. In my next video, I will go over GCEdit and try and show you how GCEdit is meant to be used and how you can edit G-code files a little bit faster and a little bit easier with our new G-code editing software. And I will also go into MC Lua Editor and show you how we can test the wizard and see a wizard file being run. And after that, we'll get into some of the running of WX Mach and its features. Thank you.